I'm going to present this work that's together with Joel Walthall, very generally about, kind of a topic that's very current, especially in, in Europe with regulators being very worried about this. So in general, right, it's about platform bias and how we can actually detect it. So just to kind of give a little bit of a, yep, this works better, okay. Yeah, just kind of, very generally, self-preferencing, whatever that means, is now illegal. As of a couple of weeks ago, the Digital Markets Act in Europe has come into effect. And now basically what we have is a situation where platforms are no longer allowed to self-preference. And that is great, maybe, because we don't know what self-preferencing actually really means. So that's basically where, we want to kind of come in. The way we think of this is that, the self-preferencing is, this regulatory action is basically ahead of what research has been doing. So we kind of think of this as, there's really this very urgent need to understand what self-preferencing is and how to measure the size of self-preferencing as well as just the welfare consequences of it. And so really the big problem here is that it's kind of hard to tell, unwarranted self-preferencing from from putting your own product somewhere higher than, other products because they're just better, right? So the canonical example here is something along the lines of, think if you look for Amazon, on Amazon for batteries or something like that, and you see that the Amazon Basics batteries show up first. Question is, should they have shown up first? Or should they be the first search results, or should they be a little later? Because in reality, Duracell batteries are better, right? So that's basically this idea of telling apart, whether the search results, the search rankings are warranted or not. So with that kind of in mind, the actual questions that we have identified that we think would be really nice, especially for regulators to have a very clear understanding of, are essentially these three. First, what is self-preferencing? Second, how can we detect it? And third, how bad is it? So these are essentially, again, we're trying to put this, there's a bunch of really smart marketing scholars and economists or something who can put together a really fancy model that really kind of gets to the point of this, all smarter than me. I can't say if they're smarter than Joel, but they are smarter than me. But so we're making this like way simpler than anything, that other people might have done, right? So that's basically the big idea here. So the generic setup that we're thinking of, right? Think of search results rankings. For example, you want to go to San Diego. You're looking for hotels, right? You get on Expedia or something, you get your list of, different products. I did this yesterday and learned that I spent more on my hotel than I could have if I bought it yesterday. But that's not the point of the talk today. Exactly. So instead, right, so what we have is exactly, we get to choose among this list of products that are presented to us in some order. And the platform chooses this order, right? They choose these search ranks. And the way that they choose these rankings, these search rankings, is to serve some kind of objective. The way we think of this is they are trying to kind of, weigh the objectives, like three different objectives. The objectives of the consumers, of the sellers, and their own. And our interpretation or our definition of self-preferencing is basically that self-preferencing is present if the platform ranks its own products higher than whatever would maximize some sort of combination, some weighted sum of consumer and seller surplus. Now, we can of course argue if that is the right definition, and I'll see if we do, but basically, right, we need some definition, and based on the regulatory documents or something, it's not clear that regulators in Europe at least have a definition, so we're offering this up with a couple of caveats that I'll go to. Yeah.
So the seller surplus is the other seller surplus, or the platform is the seller surplus?
So in this case, it is the platform and others.
Okay.
So all people who sell a product on this platform, which could also be the platform itself. Yeah. Yeah.
And I guess we're interpreting this in a pretty static sense, as opposed to like we're thinking long term, like maybe we think certain sellers would participate more or like develop new products if they were ranked better.
Right.
And dynamic sense, therefore we should kind of have them rise with the rankings. So we're just kind of ignoring all that.
We're basically ignoring all of that, right? Exactly. Of course, in reality, self-preferencing is only one type of behavior that regulators are afraid of. There's other types that are saying precluding entry from others because of how you act now. We're just keeping this very statically for today. Yeah.
Now, the common definition seems to be when you're a platform and you compete with your own customers, right? The batteries is a platform and I'm also selling.
Yes.
And that becomes more, it seems like what you're
Yeah.
defining here is like more self-interest versus self-profit
Yeah.
because you have two competing businesses.
Exactly. So in this particular, okay, so of course, on Expedia doesn't sell its own hotels, so that made for a more fun slide than something else. But yeah, exactly. So we kind of think of this as, I mean, yeah, they can compete with other sellers, and but in general, we can also imagine a world where they, you can think of this as maybe something where like self-preferencing can come from getting a higher commission on selling some products than others. And we're okay with that. We can also just call it bias instead of self-preferencing. So we can go with either of those terms.
But that's not new, right? A supermarket does that.
Yes,
Car dealers do that. Any business
Exactly.
does that.
but regulators are worried about this. Yeah. Yes, exactly. So with all of that said, yes.
So I'm curious, didn't they have a definition when they passed the regulation?
Yeah, I mean, the definition is essentially don't preference your own products.
So
It's
kind of vague,
not really, it's quite vague. So
but
yeah.
that could be a good thing, right? They could interpret it and go after
Well,
wider
yeah,
range of people. Because I've done something with GDPR and that's exactly the same thing. It's kind of vague.
yes.
And I suspect
exactly.
it's done that so they have more latitude. The fact is they haven't done anything with it, so.
Yeah, I mean, but it's, at the same time, and of course, those are actually conversations we can also really have over lunch or dinner, right? But, in a way, at the same time, when you have very vague definitions, it's easier for places like Amazon to be like, oh no, but that's not what we think self-referencing is. So it goes both ways, right? Yeah. All right, so with all of that, what I'll talk about here in the next couple of minutes, I guess, is, right, so I'll provide you a very simple theoretical framework that basically just, lays out these platform incentives with the, with the caveats of, how to kind of, yeah, fit all of the incentives or all three types of players into one framework. We're gonna then kind of use this theory, this simple framework, to motivate two methods of bias detection. One where we basically, we'll call this the conditioning on observables approach, and one that's the outcome-based approach. And again, I'll go into a lot of detail on those. I'll show you with some Monte Carlo comparisons, basically the advantages of one versus the other. And you can already tell we're kind of, we like the outcome-based approach a little better. And yeah, and then, we'll actually bring this to three different data settings that kind of show that really these two different tests that have been used have, might lead to very different results. And then we add a little bit of a structure around it to really talk a little bit about the welfare effects as well. I want to say right now that once we get to the data and the empirical comparisons, I'll mostly just make a call for, trying to get better data. These are potentially data, that regulators can really get. We as outsiders might struggle a little more to get these data. So it's really kind of a paper where ideally regulation might actually follow a little bit here. But with all of that said, to actually get to a little bit of the model here, very simple. The idea I basically already had on slide 1 or 2. We think of this, okay, there's two parts to our model. And again, the model is probably intermediate microeconomics. On one side, we have consumers. They are going to choose among, the products that are presented to them. And somewhere in there, the higher the product search ranking, the more likely you are to purchase that product, right? We know this from a lot of different models that basically tell us that. The other part of the model is the platform. The platform, of course, say they have 50 different products to rank. They therefore have n factorial possible rank orderings. N factorial is a large number. I checked recently again. It really is. So we'll go with that. Okay. So then, so instead, what we're kind of thinking of is, okay, we can't think of all n factorial possible rank orderings. Instead, we'll think of this as, the platform basically just having two dimensions of decisions that they have to make. On one end, they have, they kind of try to decide how to balance how much, like the interests of the consumers and the interests of the sellers. And again, the sellers are the platform itself plus all of the other sellers. That's the first dimension. And once we kind of decided, okay, how much are we going to, be nice to consumers versus sellers, then we can think about how much does the platform actually want to advance its own interest, right? And that would come at the expense of likely both consumers and sellers, because, the platform might, for example, get a higher commission for its own products or something else. So with that, the way we think of this is that, without self-preferencing or without platform bias, the search rankings would basically lead to this Pareto frontier, like a welfare frontier between maximizing consumer surplus and maximizing total combined seller or producer surplus. But when we do have platform bias, for example, self-preferencing, then the rankings might actually depart from this frontier. So that's basically the entire idea. I'll draw a picture in a moment because I like pictures, but yeah.
Just a point of clarification, say consumer surplus and platform, producer surplus, you also consider platform service. Like if you think overall welfare effect on someone.
Exactly. So again, so what we think about in general is we are defining no self-preferencing as maximizing some weighted sum of consumers, and again, the producers or the sellers are the producers of all the product, including the platform's own products. But then, of course, we have that the platform has some separate profit that it gets from some other function. That's what we'll think about as this part B here of, advancing its own interests. But it's separate from that, and we're keeping that in mind. Yeah. We're remaining relatively agnostic about how we, like where their profits come from, but it's in the model.
So,
Yeah.
So if Amazon batteries are ranked above Energizer, and they're actually exactly the same in terms of producer surplus, and Amazon self-preferences and then steals the sale from Energizer, are we not still at the frontier of max producer surplus?
In that case, yeah.
Okay,
If they were exactly the same, then that should be, right? I mean, then on average, they would have the same rank. If they have one rank better, mathematically, it's, it's not gonna, if they're always one above the Energizer, that would probably be, a rank bias of one position or half a position rather, because without bias, they would sometimes be ranked first, sometimes be ranked second.
so I could think of this as like a strict definition of self-preferencing, and there may be additional definitions that are less stringent.
I think so. Yeah.
Not being at the frontier does not mean that the consumers would be better off with self-preference, right?
So if you're not at the frontier, it is like there are other options that would make consumers better off, but it would also make producers worse off, right? Exactly. So these are a lot of questions that I'll actually get to in a moment. So I'm I'm still keeping track of time, but yes.
This might be better for the model, but just another kind of question about the frontier. If I was doing other preferences, actually raising other products in some regard, I would also move away.
Yes. So exactly. So I realized that much of what I've talked about so far is actually, I called it self-preferencing. We can think of it as bias more generally as well. So I'll have one example, in the data where we're thinking of maybe if there's some bias in favor of chain hotels versus others. We can also think of it as, in terms of Spotify, is there, like a bias in favor of majors versus, versus others. And exactly, I wanted to see if the Spotify person's gonna look up. Yes.
Imke, feel free to shut down audience
Exactly.
questions at any, if you need the remaining time to finish it.
We'll find out. I'll probably find out 5 minutes before the end if I
Okay.
can. All right. Okay. So with all of that said, what we actually need exactly is, we need a way very generally, and everybody, who wants to, who's studying these topics, we need a way to kind of, map the product characteristics, prices, and platform chosen rankings into outcomes of some sort, either quantity sold or total revenue, and then also, of course, consumer surplus if we want to weigh the two, producer and consumer interests. Of course, we can have a lot of different ways to measure demand here, right? Of course, we can have search models, we can have limited information choice models and all of that, but I already promised that I wanted to do something that I understood, so we're gonna do something simple, like a logit model, just to kind of get the point across of how to think about consumer surplus at this point. So to start off, right, the consumer side, the way we think of this is the consumer is gonna choose among J ranked products. They're gonna be ranked, their search rankings, of course, come from the platform. We think of this as, okay, utility as kind of, some rank independent utility, delta zero. And then we also have this causal rank effect. Now, again, I understand this is a little odd potentially because we're thinking of this as the rank actually affects the utility, but we're thinking of it rather as the rank affects the probability of purchase. Okay, so we understand that in fact, yeah, I'll have that in a moment, but so we'll have a mean utility that of course doesn't have the error term, and we have the rank independent mean utility, this delta J0. And again, we all understand that this delta J0 is of course also related to rank, right? On average, a platform is probably going to put better products first. That's part of the delta J0. But then there's also this rank effect on purchase probability. And we'll leave it at that, okay? So that's basically it. We're gonna, on average, put better products first. That's in delta J0, but then there's still a little bit, maybe because of attention or something else, search costs. There's also a causal rank effect on skills. Now, the ranking, therefore, affects everything, right? So the ranking is gonna affect the probability of purchasing product J, because somewhere in the logit market share framework, we'll have this e to the gamma rj in it, the causal rank effect. And of course, gross seller surplus across products is therefore, it's basically the same thing, but with the price in there. That's going to be dependent on the rankings, and the consumer surplus, of course, as well. So all of these things actually depend on rankings, and therefore we care. We potentially care. So then, thinking about what the platform actually chooses, again, n factorial, large number, smart marketing scholars have figured this out, but we are doing it simpler. So what we do is we start with two welfare frontier extremes, right? We can imagine one world in which the platform only wants to maximize consumer surplus, right? In this consumer-centric world, what we basically do to maximize consumer surplus is rank the products in descending order of this ranked independent mean utility. Put the best product first, the second best second, and so on. That's it. That's going to maximize consumer surplus. At the other extreme, the platform is not going to care about consumers. It's basically going to care only about producers, about the sellers, right? So what they do there is basically they should rank by rank independent variable profit. So still the rank independent utility, but times P minus MC. Yeah.
Can I clarify, how do you think about the rank independent utility as also being functional prices and product characteristics and everything else?
Yes, exactly.
That's kind of, producers will expect how platforms rank. So I assume they expect
Love the
price,
question.
right?
So you're thinking, okay, so we're not going to change the other product characteristics necessarily, but we might change prices, you would think. It's like I planted somebody in the room. Yeah. So yes, of course, that is a possibility. Let me tell you a little story about something that Joel did. So basically somewhere, so it turns out, right, so one thing that we looked at, because this is of course a concern that prices might be endogenous, we have looked at how Amazon's rankings of its own products changed once the DMA, or the Digital Markets Act, was announced. Turns out, after the Digital Markets Act was announced, basically last fall at some point, all of a sudden Amazon's products were got worse rankings than they had previously gotten. So there was a distinct shift in what the rankings, the search rankings were for Amazon. And we looked at, or Joel really looked at how the relative prices of Amazon products versus non-Amazon products changed when there was this distinct change in rankings. And they did not. So that is my way of saying, yes, theoretically, totally very reasonable thing to think about. Empirically, this doesn't seem to be a thing. And look for NBR working papers in the next couple of weeks where you'll have a paper. So, but yes, totally, thank you. And that was totally worth the time that I spent talking about. Okay, so with all of that, yeah, so we're gonna treat the prices as exogenous, but we think we have some reason to do it. Other than it's really hard not to do it. So in addition to treating prices as exogenous, we are also, but just for our exposition, going to treat marginal costs as zero. If we knew marginal costs and they were positive, then all of the math follows just as easily. That's basically it. If we don't know marginal costs, we have the same issue as most IO economists and everything. So anyway, so then basically, right, the welfare frontier, the Pareto frontier is going to come from some weighted sum of these two extremes. This is what it might look like, right? So on one end, where we rank according to PJ times e to the delta 0, that's going to maximize revenue or producer surplus if we, pretend like marginal costs are 0. And on the other end, if we just rank according to e to the delta j0, we're going to maximize consumer surplus. Now, we can take a weighted sum of the two. Of course, we see that, oftentimes when we maximize revenue, consumer surplus also increases, all a part of the model here. But we can define this frontier as kind of this index function, I star, that is, some sum of the log prices and the delta j0. And this really has, this has very intuitive endpoints. For example, if kappa 1 and kappa 2 are exactly equal to each other, that's when we maximize producer surplus. If kappa 1 is equal to 0, then we only maximize consumer surplus. And what can happen is, we can kind of see, depending on what the weights are, we'll find some point on this frontier. What happens if we do have possible bias? Then, and for example, there could just be a higher commission. I understand there's a very blurred line between bias and profit maximization. But if we have that, then basically what we'll have is some other factor that is, for the platform dummy that affects basically how you rank products, this index that you create. And again, if the psi is equal to 0, then, then we're just at the frontier. But whenever psi is not equal to 0, that'll change the rankings. For example, if the psi is positive, we'll put, we'll put a higher weight on platform products, and that's going to deliver kind of this solution that might be inside of the frontier, right? To get to Michelangelo's point, we could still have higher, higher or lower consumer surplus, but it would come at the expense of others. So, with all of that said, I want to actually, I want to go from this point here to actually give a little bit of an idea of how this framework fits into a bias test. And again, we have 2 tests for that, but we basically are just starting from this index function, this platform supply function. First off, we can think of this, for this conditioning on observables test, right? So again, we have our index function, some function of price, the delta j0, and the platform dummy. Now, suppose the index is cardinal and linear. Okay. Joel's delivery is better. It's okay. Right, then basically we can think of this, okay, just estimate rank as a function of price of this, rank independent quality and of whether this is a platform product. That's basically the whole idea. This is what we call this conditioning on observables approach. But of course, we can imagine that this rank independent quality is hard to observe, right? So because we don't observe it, what we'd usually do is we would regress ranks on everything we can see, right? That's the product characteristics that Andre said we can change, and also the price, or that, that we agree we can change. But basically, right, so that's basically it. So instead of having a delta J0, we just add the axis in here. Okay? And then again, we can estimate this function. The psi term here would basically provide this measure of bias as long as as long as we understand regressions, as long as this dj is not correlated with the unobservables, right? This means as long as the axis control for all other effects on demand. That's of course a tall order. Okay? In reality, we can imagine that maybe the Amazon Basics products are better than the Energizer products, or are more popular among consumers than the Energizer products for things that we can't capture in the axis, right? Like maybe with same thing with storage bags and blazers and razors and all of that, or something, going with Shank's presentation about, like some things are less standardized, it's going to be even harder to really kind of capture it, right? So that's the first thing. Now, so yeah, that's basically it. The second potential test is something where, we instead of just looking for controlling for all observables of a product, we look at the outcome, right? The OB is the outcome-based approach. So we can kind of think of this as, first, again, the platform. Think of these two different products, a platform product and a non-platform product. They're both going to have these indices here, these index functions. And if they have the exact same value ij, then, if there is no bias, so the psi is 0, then they'd actually have the exact same quality. Okay? But if there is bias, say psi is bigger than 0, then the platform product would be, that gets assigned the same rank would actually be worse, because everything here that's not highlighted basically really captures the quality, and that would be worse for, if the psi d term were positive. Okay? So this then basically gives rise to this other test where we basically say at the same ranking, right, given the same index function that gives them the same ranking, if the quality, right, which we can actually proxy just with a log quantity in this case, at the same rank fixed effects, conditioning on prices, if the quantity sold is lower for Amazon products or for platform products than for other products, then this product shouldn't have been ranked this highly. It should have been ranked lower. And that's basically, that's the entire idea behind this outcome-based approach. And yeah, these are the two ideas. Okay, Rob.
Maybe there's a benefit just because the quantity is higher because just get as Amazon.
But that's fine, right?
So is this self-referencing or is like if you put it in the same rank, people just prefer that?
Exactly. Exactly. If Amazon, that's actually really the point, right? So if people prefer Amazon, we'd get, I mean, actually that would, sorry. If at the same rankings, Amazon products get sold more than non-Amazon products, what will show up is this psi term will be positive. This in fact would suggest that Amazon should put its own products higher, even better on the rankings. This would be like bias against its own products. Right?
What about stocks? Was it Amazon is always better to keep stock than other products?
Oh, I mean, you're thinking if they run out of inventory? Yeah, that we won't be able to capture. Yeah. I mean, yeah, we would interpret that as sure, bias against Amazon. Yeah. I don't know how often they run out of stuff, to be honest. Right? Think of digital products. Yeah, I'll do an example with ebooks, not an issue. Right?
Yeah. And so
Yeah.
Is this adjustable for like a longer term outcome? do we have to focus on static sales?
That's a wonderful question. Yeah, so not necessarily, right? In a way, anything that can basically proxy for the inherent quality or popularity among users could fit in here, I think, but the way we're thinking of this, as I mentioned earlier, is more in a static way. So yeah, I'll think about it more over lunch or beer or while hang gliding over the coast. Exactly. All right, so with all of that, okay, so what we actually, I do want to tell you a little bit about, how this approach would actually be implemented in, if we had real data. So what we need for that, right? So in a way, I'm kind of pushing toward the outcome-based approach rather than the conditioning on observables approach because of unobservables, right? Which we don't have to worry about in the outcome-based approach. But basically for all of these, for both of these tests, we need to observe rankings and whether the product is potentially biased, right? A platform identifier. And then if we do the COO approach, we do need all of the axis characteristics that would legitimately be predictive of ranks and sales. We don't need that for the outcome-based approach, but we have a different tall data order, which is we actually need to observe the outcomes, right? So again, I understand we can't necessarily see the outcomes, then the best we can do is the COO approach. If we go further and actually think about the welfare analysis, then we need all of the above and also actually get the causal rank effect estimate, right? So separate from the inherent quality of the different rankings. So with that, I don't know why I put this, though I do know because I thought this was going to be a horse race, and that's what I'll do, just very briefly, I'll show you Monte Carlo simulation results, but very simply, we're thinking, okay, the expected sales are going to depend on some observable X's, some unobservable Z's, and on the rank that's assigned, right? So we also have this platform indicator that is potentially correlated with Z, with the unobservables, right? And then what we'll do is we'll simulate a bunch of data for ranges of bias, psi, and for correlations of the unobservables with the platform indicator, right? And then we estimate basically whether we find bias or not using the conditioning on observables and the outcome-based. Very simply, what I want to look at is on the next slide, if we see a lot of yellow, that's good. If we see a lot of purple, that's bad. That's it. So at the top, we see the conditioning on observables approach. Basically what happens is they oftentimes, and it makes sense, right? Once we have bias, once we have correlation between platform indicator and unobservables, we're gonna sometimes accidentally identify something that's just a correlation as actual bias, right? That's basically what's going on in the top row, and that's it. For the outcome-based approach, what we have instead is sometimes we fail to see bias, right? So again, the y-axis is bias. Sometimes we fail to see bias when there is bias, but the bias is small, like a third of a standard deviation of prices or of quantities or something like that. So that is, of course, made up with our own data. So it feels like we might have, stacked the deck a little bit in our favor. So let's actually use real world illustrations as well. I'm going to use 3 of these in the next 10 minutes. First, I mentioned we have Amazon Kindle daily deals. So Kindle ebook data. So it turns out for Amazon, each day they have one web page where they basically show 50 ebooks, and they are offered at a discount. They're approximately 50, and they're displayed to all of us in the same order. It's the same products. We each see the same order of these products. What's nice is that about 20% of these are actually published through Amazon. So there's a clear potential for self-publishing, self-preferencing. Self-publishing has already happened to them. Exactly. So there, right? So we can actually, we have a clear setting where self-preferencing is a real issue, and we happen to observe some data as well on sales and so on. It has some other shortcomings that I'll talk about briefly. So any results that I'm showing you today, take them with a grain of salt. This is why I'm only getting to them in the last 10 minutes. We also have the Expedia hotel searches from the contest from 2013. Lots of searches, 400,000 searches, lots of listings. And what's nice is, of course, that some of these searches are actually randomized, or the search results are randomized. So what's kind of nice here is that we actually can get a causal ranking parameter. But there's no real self-preferencing, so instead we're looking at maybe is there bias with respect to chain hotels. And lastly, very briefly, we also have something on Spotify, the New Music Friday from several years ago. That's actually Luis Aguiar and Joel and another Waldvogel. And there we use 20 of the 50 ranked songs in 26 countries over 35 weeks. Bunch of listings for which we observe whether or not they're in the top 200 in the country at the time. And if we do, then we have whether we have streaming information. So we can look at, again, possible bias with respect to maybe majors versus indies. With all of that, I'll jump straight into results, right? So again, what we do is we just run a regression, rank against observables, and also outcomes against rankings. We can see here the conditioning on observables test gives us a rank parameter, a rank coefficient of -0.27. This is log ranks. We also have, a negative coefficient here in the outcome-based approach. Both basically say there is self-preferencing. They also say, very roughly in the conditioning on observables approach, right? So the rankings are off by approximately 28%, 27% or so. The outcome-based approach actually suggests much larger ranking, like biases in ranking terms. This is again a time, so basically this suggests there is self-preferencing, but I do need to mention here again that the data are really not great. And in fact, they are bad in a way that they are differently bad for Amazon products than for non-Amazon products. So as much as I'd like to stand here and say Amazon is evil, or maybe I want to say Amazon is amazing, I can't say either of these things. Okay? And I'm not saying either of these things, except I just said them, but yes. Okay, so then we've got instead, or the second setting was Expedia. Again, is there bias with respect to chain hotels? We see that conditioning on observables, chain hotels get rankings that are about 0.7 positions worse. We also find that conditional on the ranking, chain hotels sell a tiny little bit more. So it seems like there's, that the chain hotels are ranked too low, bias against chains, but it's really tiny, right? That's it. Now, again, Spotify, and we have an expert in the room who can tell us much more about this, but basically here we do the, is that a question about Expedia? Sure.
So this Expedia has a sale, the rankings are ranked, right? And then
Yeah.
you should get nulls there, because I'm not self-preferencing the rank.
So-
It's a good test for your thing,
Yeah.
and you should get null, there was no self.
Yes, thank you for mentioning this. Of course, about a quarter of the search results are randomized rankings. These are not used here. Here, we're only using the organic
So
search.
if I run your.
Exactly, we can see
on
it.
that quarter, you will get null.
Yeah, I like that. Thanks. Okay, yeah, so with Spotify, this one, we really kind of just wanted to highlight this here because if we do the conditioning observables approach where we control for danceability and many other things that have to do with music, we find that, majors are actually ranked about 1.2 positions higher than they should be based on the observables. But we also find that conditioning on ranking, majors have more streams. So this is really kind of the prime example of if we use the conditioning and observables approach, we can't capture everything that makes this song a song that was picked up by a major. Okay, so here we basically find the opposite results. So these field data, kind of confirm our Monte Carlo results that basically say there are some concerns about the COO approach. With all of that, and in the last 5 minutes, I want to talk about how we can move from this, right? We've kind of mentioned small or tiny bias, like what are these actually in terms of welfare effects? So what we're doing here is basically just putting a little bit of a welfare framework around, around these self-preferencing ideas. So for Amazon, we start off as promised with a, plain logit model. We've got, the usual difference in market share or log shares as a function of some observables, although here there are only the pre-promotion sales, and of prices, and then we have the ranking term, and then the estimated values that we get from here minus the causal part of the rank coefficient will give us our estimated kind of this, in rank independent quality. So we can use the rank independent quality and estimate the supply function, right? This is basically just the index function, but with a rank independent quality that we estimated. Getting to the point here for the demand, basically, we have regular demand coefficients, a negative price coefficient, but that's not exactly causal. Negative rank coefficient, also not necessarily causal yet, but we also observe, over many days, we observe some products, some books more than once and at different positions. So with the book fix effect, we get something that's a little closer to a causal rank coefficient. And if we use that, we find 0.335. So it's good news that the causal rank coefficient is smaller in magnitude than the total rank differential. Now, with all of that, this allows us to calculate the rank independent utility, and then we can estimate the supply side. What we basically find here is, one in a linear model, and then also with the rank ordered logit. But very simply, we find that somewhere here, they value both the rank independent, like the delta J0, and they also value the price. So this tells us that there is some balancing going on between consumer and producer surplus. And then we find a relatively large coefficient on the platform product that suggests there is potentially large bias. I'll leave out the Expedia stuff, but basically, if we were to then remove this bias term, like this psi times the platform coefficient, platform dummy, the new rankings, this is the distribution of the Amazon products rankings, they should all be between 40 and 50, right? Again, the data aren't great, but that's basically what we get from this. And here is then kind of this whole idea in terms of the actual welfare, where we find one, if we use the debiased term, we get somewhere here that's pretty high on the consumer surplus side and somewhat lower on the producer surplus side. That's the debiased ranking. But the bias itself gets us to a point that's here. So the bias itself forgoes about 3.3% of the debiased consumer surplus and 5.3% of the debiased revenue, right? So again, I think, the nice thing is this is what we see for the for Amazon, for Expedia, they're basically on top of each other. So really no big deal in terms of bias in that term. And with that all said, I just kind of want to finish again, right? So because we have all of this platform regulation right now, we do need ways to test for and evaluate this possible bias. And what we're doing here is just kind of proposing or presenting a pretty simple equilibrium framework that one motivates the tests that people have been using, highlights the benefits and the costs of each of those tests, and in general, I think we're if we have the right data, then I can actually say a little more about each of these. We can say more about how harmful the self-referencing is. And so with that, thank you for all of your comments, and I look forward to more.
Good morning, everybody. My name is Dante Donati. I'm at Columbia University. Let me start with two fun facts. First fact. Maybe it's a coincidence, but the first two discussants in the room were actually me and Tommaso. We're from the same city in Italy, in Arezzo. It's very, very small town in Italy, which is, I find it very, very, very interesting. And second fact, if you combine the comments by Panit, Carl, Ron, Ken, Andre, Michelangelo, and Justin, you basically create my discussion. So probably there's nothing much left. But I'll try to do a good job. And thank you for inviting me to discuss this paper. So the motivation, right? So you go on Amazon, you search for a keyword which is keyboard, for instance, what happens most of the times, you're gonna see Amazon basic products on top, right? And so this can be an example of self-preferencing on this platform. And has been under scrutiny by different competition authorities, both in the US and in the European Union. Why? Because, and basically what they say is it's unlawful as long as it materially harms competition. Very vague, okay? So what this paper tries to do is to add to this discussion. So the authors define what platform ranking bias is. They try to measure it using data and also using, simulated Monte Carlo simulation. And finally, they try to evaluate welfare consequences of bias. So very, a slide to summary, to summary these paper results, the definition, which I really find, very simple and powerful. A platform ranks its bias when it delivers outcomes that are interior to the welfare frontier that maximizes consumers and seller surplus. Okay. Then what they do, they test for this bias using a very simple structural model. So they come up with two different approaches: the CO, so the conditional covariance approach, and the OB approach. And so Imke already explained the pros and cons of these two. They show how they perform with simulations, but also with platform data. And for example, what they find is Amazon books receive ranks that are about 42 times better than non-platform books on Amazon. Okay, that's for instance with the OB outcome-based approach. And finally, they evaluate welfare, so they compute the counterfactuals from Amazon Expedia. And for instance, again, an example of results, bias rank at Amazon reduces consumer surplus and produces surplus by 3.3 and 5.3%, much less at Expedia. Okay. Okay, so I have two main comments on the specific part of the papers and two more broader comments. So the first main comment is, so there is a lot of difference between CO and OB approach. And I think maybe the paper can do a better job at reconciling these differences in the text, right? And actually I was thinking about the omitted variable bias, right? So the CO approach is subject to this bias, right? So if you think about the latent variable Z, that is likability of Amazon products, right? So some preference for the brand, or maybe Amazon products are better delivered faster. So what I would expect is that actually the CO approach overestimates the magnitude of a negative bias, right? So if you think about, and this is actually what Fahrenheit et al. They do in their paper. So when they add controls, the bias goes down. So the magnitude goes down, right? So if you take the simple formula for OLS bias, right? We know that so this is bias of the bias, sorry. So let's say C is the actual bias that you estimate, right? So basically what happens? So in general, we estimate that there's a negative bias if there's self-preferencing. So Z is what? Likability of Amazon. So we expect that likability of Amazon is negatively correlated with rank because it's higher, right? And is also positively correlated with Amazon brands, let's say. That's the indicator for the platform. So basically on the right-hand side, you have something negative, on here you have something negative. So if there is a bias, if there is an omitted variable, this COLS should actually capture something which is larger, right? More negative. But this is, maybe I didn't perfectly understand, and maybe you can explain that better. But what I find in general is that Monte Carlo simulations, for instance, are more likely to under-detect this negative bias in these specific regions. And also in the data, right, the CO usually yields much smaller estimates than the OB. And so to me, it's not totally clear why happens. Maybe most likely I'm wrong, but maybe you can explain that better. Second part, definition of bias. What is a bias here, right? So I really like the definition that they provide. It's very intuitive, and it's based on these two dimensions of combining consumer welfare and producer welfare or service. What I would like to add, and think Ron had a comment on this, right? What is platform surplus in this context? I didn't completely understand where it stands, right? And so I would actually encourage to better kind of explain what is the platform incentive to deviate from the frontier, right? And maybe what is the trade-off, right, that the platform faces, right? Because of course, if you self-refer, you make higher profits on your product, but at the same time, you lose some commissions on the other products. And so maybe there's, for sure, there's a trade-off that maybe you can better explain. And second, maybe to Michelangelo's point, so is the Ethereum solution profit maximizing or maximizing platform revenue? So that's something I didn't totally understand, okay? Because intuitively, this should depend on the on the commission rate, which is unobservable, and also these may vary across products. So I think what you can do, for instance, is maybe you can basically include the commission in the model and make some simulation. Let's say commission rate is, it ranges between these two numbers. What happens to your welfare computation? And I think the nice thing about commission rate is that is a signal or a some kind of a signal for platform market power, right? And the whole regulation is aiming at regulating Amazon or big players, right? And so I believe that this commission rate, it helps you say, okay, if you have high commission, that's what happens. These are the big players. If you have low commission rate, then smaller players should, and of course you can differentiate between the two. So more generally, probably Justin's point was about this, right? So if you read the regulation, right, let's say self-preferencing is unlawful if performed in a manner that would materially harm competition. Okay? So this paper provides a very nice way to detect short-term welfare implications. But if we want to do something more normative analysis, right, we should probably think about how do we study competition, right? So how does this self-preferencing impact equilibrium in the long run, right? And for that, you probably need more like a general equilibrium approach or model that captures these long-term counterfactuals, because these can have effects on prices in the long run, can have effect on quality in the long run, can have effect on entry and exit. Who are the players that stay in the market? Who are the players that don't enter the market, and those who exit the market, right? And this paper tries to address part of that. And actually, the authors like Lee and Mazel, they find a small positive long-run welfare increase. And so maybe you can kind of try to reconcile your findings with that finding. My second general comment is about heterogeneity in consumers, which I find very interesting, right? So assume that you search keyboard on Amazon. So what happens most likely is that you see these results, right? You see Amazon Basics on top. Now, this happens with self-preference, right? Now, we might have two counterfactuals, let's say. Counterfactual one is, let's say you ban self-preferencing, and this is what happens. No name brand on top. And you have Logitech always at the bottom. So this is counterfactual one. And then you have counterfactual two. Gaming platform, gaming keyboard, and Logitech. These are actually real outcomes, okay? They can both happen. So what would you prefer, right? If I say I ban self-preference, would you prefer this or that? And I say, well, it depends, right? It depends. If you are naive, right? Or if you are sophisticated, right? So if you are a naive consumer, let's say Tommaso is naive, maybe Tommaso would actually like these rather than that. While maybe Davide is more sophisticated, likes gaming, so he prefers the gaming keyboard, right? So the question now is, maybe self-referencing helps one type of consumer better than the other. Because maybe instead of, so if you think about Tommaso who's naive, right? Maybe self-referencing helps Tommaso to pick a better product. Because this no-name brand likely is not that good. But if you are Davide doesn't need this, right? Now Davide just wants this because it's more sophisticated. So I'm thinking there's a lot of data. Why can't you actually segment, right? And is actually segmentation part of improving in this context, right? Can he actually help the overall outcome? I have a list of specific comments. I'm not going through these. These are for you. So just to sum up, I really like to read this paper. I think the question is very relevant, important, fills in an existing gap, and this literature is so young And so it's really great. I think its simplicity is really powerful, and you know, the framework itself is very powerful. I know I was able to read it and kind of understand 80% of it, so I was pretty happy. Usually with structural papers, you know, I need much more time. It's great. So just my main comments wrap up here. So results appear to be very context and data dependent, as you already said. But I think, you know, authorities can apply this with their data. Okay, so they can basically take their model, try to understand and measure bias with the data that they might have access to in different products and different markets. But I think we have to be aware that these are all short-term outcomes, and it's much less clear what happens to competition in the long term. Okay, so that's the main point. All right, thank you so much.
You want to say something?
All right, I'll say something very quickly. Thank you. No, exactly. I mean, just thank you for the comments, and also everybody else for the comments throughout. Yeah, no, super valuable for sure to present this here. And I think one thing too, I mean, just very quickly with the heterogeneity, I think that's, you know, just something to think about rather than keeping everybody from lunch. Right, I mean, so the Expedia setup, of course, is actual personalized, you know, like search results, and that's perfectly fine there. So, you know, it's like, I think everything here can easily be set up for this consumer heterogeneity if we observe individual searches. But yeah, I really like this idea of thinking more about the long run and all of that as well. But yeah, thanks.